The CR-10 is a decent large volume 3D printer, but with its nozzle and feeder setup takes ages to print bigger parts. I'm impatient and honestly don't have a good feeling letting it run unsupervised for a longer period of time. So I added an E3D Titan Aero Direct Extruder with a volcano hot end. This finally makes it a great printer for printing with big nozzles and at high speeds. In the last video we prepared the software for the CR-10 and flashed the custom firmware. In this video we'll add the hardware. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. The E3D Titan Aero is a direct extruder, which means that the motor that pushes the filament into the hot end sits directly on the X-axis carrier, which has its advantages and disadvantages. Most importantly, with this setup you eliminate the whole compliance of the Bowden system, meaning that you can extrude material much more precisely and don't need huge retracts to avoid printing artifacts. This is actually one of the reasons why I did the upgrade, because I had severe problems with printing quality when I used larger nozzles, which is now almost completely eliminated. Then they are easier to use with flexible filament because the filament path is shorter and more restrained, reducing the risk of filament kinking in the Bowden tube. The disadvantages of such systems are that they are nowadays, with a flood of Chinese printers, way less common and therefore more expensive. But a severe problem is weight. If you remember Newton's second law from school, you will note that the force that you need to accelerate a body equals its mass multiplied by the acceleration. This means that with a higher mass of your x-axis, you will need more force or more torque from the motor to accelerate the print head. Since we are relying on the fact that no steps are lost during the printing process, which would cause layer shifts, we either need to use slower acceleration values or increase the torque of the motor, which could lead to thermal issues and so on. But this is actually not the biggest problem. With the added weight of the extrusion motor, we introduce low frequency oscillations in our printer, which result in the well-known ringing artifacts at all of the locations when the printer changes its moving direction. The CR-10 uses rollers and V-slot extrusions as linear rails, which is not the most rigid setup and makes the vibrations even more problematic. So it wouldn't be a good idea to just strap any direct extruder on your CR-10, because you would probably make your prints worse or slower than before. This is where the Titan Aero extruder comes in, which was kindly provided by E3D. This is a compact and lightweight extruder which, I thought, was well suited for this upgrade. Unfortunately, I had some serious problems with it, to which I'll come later. Due to its internal gear reduction, it can be used with a pancake stepper motor, and the extruder body also acts as a heatsink. It is fully compatible to the E3D ecosystem, so you can use all of their heat blocks and nozzles with it. For the reason that I want to print with big nozzles, I also switched out the standard heat block for the volcano, which is more suitable due to its longer heater zone to melt a lot of material in a short time frame. The upgrade of the CR-10 does require some skills and will not be easily reversible, since we will need to cut some wires. You will be doing that on your own risk. Warranty, if there ever was any, will be voided and you can't make me responsible for it. There is a realistic chance that you ruin your printer. So we will need some 3D printed parts beforehand, mainly the extruder mount, which you really should print out of a high temperature plastic like ABS or ASA. If you have a CR-10 and not a CR-10S, you will need to flash a bootloader to the control board, because otherwise you won't be able to flash new firmware. I also made a video about this, which you can find in the info box or in the description. You'll also need a radial fan to replace the old part cooling fan, and a set of M3 bolts in different lengths, including nuts and washers, is highly advisable. As I already mentioned before, we will need to cut and solder some wires, so a soldering iron and shrink tubing is a must. I intentionally did not add a bed level sensor, since even though they are convenient, they just try to improve your prints if you didn't level your bed properly in the first place or the glass you are using is not flat. The Marlin firmware we will use has a very nice manual leveling feature, which makes setting up the bed very easy. I want to add a filament runout sensor in the future, but that's something for another video. So let's dive right into it. At this point, I assume that you have already uploaded the custom version of Marlin, which is set up for the Titan Aero extruder. Again, make sure that your printer is turned off and unplugged. Remove the fan shroud and unscrew your hot end. Then continue and remove your feeder motor. While there, make sure that your lead screw is properly fixed. Mine wasn't. You can remove the heater cartridge and the thermistor at this point from the heater block, and this way remove the whole hot end assembly or directly snip off all the wires, because we will be doing that anyway later. Make sure that you mark all the wires to not mix them up later. Now take your printed mount and bolt it to the X-axis carrier. It might be a good idea to add some Loctite at this point, that it doesn't rattle loose over time. Now you can basically start to assemble your Titan Aero by following the guide E3D provides on their page. Make sure that the flat on the stepper motor shaft doesn't have a burr. Mine had, which I noticed too late. The problem is that the idler arm is directly running on this shaft without any bearing. Even though the arm is made out of a bearing material, it wore out quite quickly and created additional friction. So if you feel something, try to smooth it as good as possible. One variation I did was adding a volcano hot end instead of the normal heater block, orientated in a way that the heater cartridge is facing towards you. Otherwise my part cooling fan nozzle will not fit. I also added one of the NEMA 17 heat sinks, which I had to slightly modify that I can bolt them to the stepper motor in all 4 corners. Otherwise the sink was not properly connected to the motor and would probably act more as insulation than as a heat sink. Make sure that the new bolts you're using are not too long and block the threads on the front side. Either cut your bolts to length and use nuts and washers as spacers. Connecting the wires is pretty straightforward. Polarity for the heater cartridge and the thermistor doesn't matter. The new part cooling fan connects to the remaining black and red wires, and the axial fan for the heatsink connects to the blue and yellow wire, where the yellow was positive, and connects to the red. For the stepper motor, I snipped off the connector on one end and then soldered together the leads in a way that they connect to the new stepper as they did for the old one. Now add the new part cooling fan to the holder and fix it to the extruder assembly. Put the part cooling fan nozzle into place and you should be all set. What's now left is just some cable management and adding the spacer that the homing position of the C-axis is in the right ballpark. Let's turn on the printer and make sure that the temperatures are right and all the axes go into the right direction. Especially pay attention when homing your printer for the first time that the nozzle does not crash into the glass. Level the bed and you should be ready to go. Now let's talk about the problems I ran into with the Titan Aero extruder, which kind of drove me mad in the beginning. Actually, all the problems I had were related to the extruder motor losing steps, resulting from several reasons. I already mentioned one before, and this was the burr on the idler arm. The next problem was that one of the bearings, which is for the big gear, is bad on mine, and as soon as I tighten the bolt on one side, the extruder jams. As hard as it sounds, but I just ended up not tightening that bolt at all, which seems to work fine at the moment. Then I had the feeling that the general motor current is set too low for the small pancake stepper motor. For this reason, I opened the electronics box again and adjusted the potentiometer, which is for the extruder stepper. I ended up in the 10 o'clock position, which results in a reference voltage of around 1 volt. This got rid of lost steps and did not overheat the stepper motor and driver so far. A thing that I learned was that extruding some material by hand from time to time, or just turning the big gear by hand, gives you a great indication if everything works as it's supposed to. And that's basically it. I have already printed like 50 hours on the Titan Aero, and besides the problems I mentioned before, I'm very happy with the outcome so far. Just for reference, I printed a 3D Benchy with a 0.4mm nozzle, and this is honestly one of the nicest Benchies I've ever printed. I printed all the other big parts with a 0.6mm nozzles at 80mm a second, what saves me more than 50% in print time. Links to the print profiles will be down in the description, by the way. In summary, the upgrade was quite complicated, also since you need to fiddle around with the bootloader and firmware. This is not something I'd recommend for everyone, because if you don't know what you're doing, you might ruin your printer. Still, for me, it was well worth it. The new firmware is great, the quality with the bigger nozzles finally is also great, and I exactly achieved what I wanted. I'm now able to print big parts way faster than before. Though I need to criticize the Titan Aero a little bit. It looks nice, but the problems with the idler and the bearing are not okay, and I hope that it's not going to fail on me soon. I hope that the guys from E3D come up with an upgrade fixing these issues, especially since I noticed during my research that I'm not the only one who is struggling with these. Maybe you have an idea which other kind of extruder might be suitable for this application. Do you think that a linear rail guide on the x-axis might even make the quality with a big extruder better? Let me know down in the comments.
So this was quite some work upgrading the software, designing the parts and putting it all together into 2 videos. If you'd like to buy a CR-10 or a CR-10S and want to support the channel, then take a look at the affiliate links down in the description. If you found that helpful, then give the video a thumbs up, subscribe to the channel and consider supporting me on Patreon. Thanks for watching, auf Wiedersehen, and I'll see you next time.